the energy which is released from this combustion is directly converted into electrical energy. Hence, they are called as fuel cell. As you can see in anode and cathode, what is actually produced in the cathode OH minus and in the anode it is water. But overall reaction is H2 plus O2 giving 2H2O. The metal gets oxidized, it releases electron, that means it loses the electron, which is accepted by the oxygen and it forms oxides. Hello everyone, this is Ambli Unnikrishnan from the Department of Chemistry, Vidhyaashram School of Excellence, Mysore. So today we are back with session 7 of the chapter Electrochemistry. That's the last session for this chapter. Okay. So in the last session, we studied about molar conductivity. Yes, the equations to calculate molar conductivity. Then how molar conductivity varies in weak electrolyte and in the case of strong electrolyte as well, right? And then we also studied the important law, which is called Rasher's law, using which we can calculate the limiting molar conductivity of weak and strong electrolytes, right? So in today's session, we are going to study about batteries as well as corrosion. By this, we will come to an end to this chapter. So let's begin with batteries first. So what are batteries? In simple words, we can say it is a combination of cells. So we have already studied what is electrochemical cell and what is electrolytic cell, right? Okay. So in batteries, whether it is electrochemical or electrolytic cell, batteries are electrochemical cell in which chemical reactions takes place and it produces electrical energy, right? So it is a combination of many of the cells together, which is called as batteries, right? So there are two types of batteries. Primary cells, you can call it as cells as well, okay? Primary cells and secondary cells, or primary battery and secondary battery. Okay, so what are primary batteries? The cells in which the redox reaction occurs only once. Okay, so we have already studied that in electrochemistry, redox reactions takes place, right? In electrochemical cells, redox reaction takes place. So in primary batteries or primary cells, the redox reaction only takes place once. That means these batteries are not reusable. Okay, so the battery cannot be recharged or reused. They can't be recharged or reused. Okay, redox reaction will only take place once and we can't reuse it or recharge it. So examples for it are dry cell, which is also called as Leclanche cell, and mercury cell. These two in detail we are going to study now. Now the next type is secondary battery. So what will be secondary then? The cells in which the redox reaction can take place more than once, or else it is reversible. We can recharge it and reuse it. Okay, cells which can be recharged and reused again are called as secondary cells. An example for it is lead storage cell, nickel cadmium cell. All these are examples of secondary cells. So I hope primary and secondary batteries is clear for you. Primary cannot be recharged and secondary can be reused again, right? So let's begin with the first one, that is dry cell or Leclanche cell, which is a primary battery. That means it cannot be reused, right? Okay. So the cell consists of zinc as anode. Okay, which is the anode, zinc is the anode, and graphite rod surrounded by manganese oxide, MnO2, as cathode. So you have to remember for each of the cells, which is the anode, which is the cathode, and which is the electrolyte as well as the cell reaction, right? The diagrams are not that important. So you need to be knowing which is the anode, cathode, the cell reaction, right? Okay, so the cell consists of zinc as anode, okay, which is the anode zinc, and cathode is graphite rod surrounded by MnO2. A paste of ammonium chloride and zinc chloride acts as electrolyte. Okay, so I hope you are clear with anode, cathode, and which is the electrolyte here. So it is commonly used in clocks and transistors. The commonly you use the clocks, right? Inside the clocks, which battery is present? Now you know it is dry cell or Leclanche cell, right? And the cell potential of dry cell is 1.5 volt. Okay. Now let's see the reaction involved in here. So in the anode, zinc gets oxidized. In the anode, always it is oxidation. Zinc gets oxidized to Zn2+ and releases 2 electron. It loses 2 electron, right? Okay. And in the cathode, manganese dioxide, MnO2, reacts with ammonium ion and accepts electron and forms MnOH and ammonia. Okay. So the ammonia produced, yes, ammonia is produced in the cathode. The ammonia produced in this reaction forms a complex with Zn2 plus ion, right? Zn2 plus is formed here, ammonia is formed here. Zn2 plus in the anode and ammonia in the cathode. Now these two combine and forms a complex, okay, right? So this is the reaction which is taking place in dry cell or Leclanché cell. So as you can see here, the graphite rod, in the center you can see the graphite rod will act as the cathode, okay, which is surrounded by manganese dioxide, MnO2. And the electrolyte used here will be a mixture of ammonium chloride and zinc chloride, okay, and the anode will be a zinc container. So the outside part you can see that is the anode and the cathode will be present in the center. In between them will be the electrolyte which is used. So this is Leclanché cell or dry cell. So the next example for primary cell is mercury cell. Okay, now let's see. It is used in hearing aids and watches. It is used in hearing aids and watches, right? And zinc amalgam acts as the anode. It's an amalgam, okay? Zinc amalgam, zinc and mercury amalgam it is. It acts as the anode. And a paste of mercuric oxide and carbon acts as cathode. So you're clear with what is the anode and what is the cathode, okay? Zinc amalgam acts as anode and a paste of mercuric oxide and carbon acts as the cathode, okay? And the electrolyte, which is the electrolyte which is used, potassium hydroxide and zinc oxide. It's a mixture of or paste of potassium hydroxide and zinc oxide. Right, now let's see. The cell potential is 1.35 volt, okay? Now let's see the reactions. In anode, the zinc amalgam accepts 2 OH minus ions and forms zinc oxide, okay? And in the cathode, mercuric oxide accepts 2 electrons and it gets reduced to Hg, mercury, okay? So the net cell reaction will be the zinc amalgam and the mercuric oxide forms zinc oxide and mercury. So this is the reaction which is taking place in mercury cell. Okay, so I hope the anode, cathode, the electrolyte and the cell reaction is clear. Now moving on to the next one, which is lead storage cell, which is a secondary cell. Okay, so the first two we had studied, the dry cell and mercury cell, are examples of primary cells. The next one is lead storage cell, which is a secondary cell. That means it can be recharged and reused, right? So let's see, it is used in automobiles and inverters. Okay, automobiles it is used means it must be rechargeable and reused, right? Okay, so the anode is lead. Okay, the anode is lead and a grid of lead packed with PbO2 acts as cathode. So anode here is lead, okay, and the cathode is a grid of lead packed with PbO2. Okay, Pb plus PbO2 acts as the cathode. Right. Now the cell reaction, let us see. Before that, the electrolyte is 38% H2SO4. So the anode, cathode and electrolyte is clear. Now let's move on to the cell reaction. In anode, the lead reacts with SO4 minus and forms lead sulfate, PbSO4, and it loses 2 electrons. Now in the cathode, the lead oxide reacts with SO4 minus, accepts 4H plus and the 2 electrons and forms lead sulfate and water. Now the net cell reaction will be Pb plus PbO2, lead plus lead oxide and H2SO4. Where did this H2SO4 come from? This 4H plus and SO4 minus here. So together it is 2H2SO4 and the electrons here will get cancelled. Okay, so the net reaction will be lead plus lead oxide plus H2SO4 gives lead sulfate and water. So this is the reaction here. So as I said, it is an example of secondary cell, means it must be reusable. We can recharge it and reuse it. So how does that reaction take place then? While recharging, the reaction will be reversed. That means from PbSO4, from lead sulfate, it is then converted into Pb, lead oxide and H2SO4, which will be regained. So this reaction that you can see, it will be reversed now. So from lead sulfate, now you will be able to obtain lead oxide and H2SO4. So this reaction can be reversed as well. So hence the lead storage cell can be reused. I hope it is clear. Now moving on. So as you can see here, this is the lead storage cell here. This is the anode, which is lead, right? And lead grids with lead dioxide is used as the cathode, right? And 38% sulfuric acid solution is used as the electrolyte. Now moving on to the next one, that is nickel cadmium cell. It is also a secondary cell. It has longer life than lead storage battery, but it is expensive to manufacture. Okay, it has having longer life than the previous one that we have discussed, that is lead storage cell. But the problem is it is highly expensive to manufacture. So let's see the reaction that is taking place here. Cadmium reacts with NiOH thrice and forms cadmium oxide and NiOH2. Okay, it is 3 here, 2 here, and forms water. So this is the reaction which is taking place in nickel cadmium cell. Right, now moving on to the next one, that is fuel cell, which is an important part. So fuel cells are galvanic cells. Okay, they are galvanic cells which converts energy produced by the combustion of fuel. Okay, so from where the energy is obtained? Combustion of fuel, like methane. For example, the energy which is released from this combustion is directly converted into electrical energy. Hence, they are called as fuel cell. From the name itself, we can say fuel cell, right? So, the energy which is released by the combustion of these fuels is directly getting converted into electrical energy. So, I hope it is clear. Okay. So, now in detail we are going to study about hydrogen oxygen fuel cell. Okay. So, in the cell, hydrogen and oxygen are bubbled through porous carbon electrodes into concentrated aqueous sodium hydroxide solution. So, as you can see here, there will be 2 electrodes here, right? These are the 2 electrodes, anode and cathode. So, this is the cathode and this is the anode. So, from here, as you can see, there are 2 openings here. So, from here, hydrogen gas, and from here, oxygen gas is bubbled into this. Okay. So, there is anode and cathode, and in between this, as you can see, there will be potassium hydroxide or sodium hydroxide solution which will be taken here. Right. Okay. Now, catalysts like finely divided platinum or palladium metal are incorporated into electrodes for increasing the rate of electrode reaction. So, in the anode and cathode, the catalysts like platinum and palladium are also used to increase the rate of the reaction. So, this is the hydrogen oxygen fuel cell. As you can see, from either sides, the hydrogen and oxygen will be bubbled into this, and in between you can see there will be concentrated sodium hydroxide or potassium hydroxide solution which acts as the electrolyte. Now, let's see the reaction which is taking place here. So, in the cathode, oxygen reacts with water, accepts 4 electron and forms 4 OH minus. And in the anode, hydrogen gas reacts with OH minus. It accepts the OH minus and forms water and releases 4 electron. Okay. So, in cathode, oxygen is releasing OH minus. Oxygen is getting reduced into OH minus, and in anode, hydrogen gas is oxidized into water. So, this is the reaction taking place. So, now let's see the overall reaction. So, when we are seeing the overall reaction, it is actually hydrogen and oxygen combining to form water. Right. So, this is the reaction, overall reaction. Hydrogen and oxygen combines to form water. Right, but as you can see, in anode and cathode, what is actually produced? In the cathode, OH minus, and in the anode it is water. But overall reaction is H2 plus O2 giving 2H2O. Right, now the cell runs continuously as long as the reactants are supplied. So, as long as we are supplying hydrogen and oxygen into the fuel cell, this reaction will continuously take place. Okay, and these fuel cells are much more efficient than the thermal plants. As you can see, fuel cells produce electricity with an efficiency of about 70% compared to thermal plants whose efficiency is only about 40%. So, these fuel cells are highly efficient as well. Right. So, I hope the fuel cell is clear for you. Now, moving on to the last part, that is corrosion. So, you might be familiar with corrosion already. Okay. So, few examples of corrosion is the commonly used example is rusting of iron. As you can see in this picture also, okay, there is a brown color which is seen on the metals, right? So, this is called as rusting of iron. This takes place in the case of iron. Okay, other example are tarnishing of silver, right? In silver vessels, you are able to see this, and green coating of copper and bronze. In copper and bronze metal, when it undergoes corrosion, a green color will be observed. And this tarnishing of silver, you can observe a black color on the silver vessels. So all these are examples of corrosion. So in here, we are going to study in detail about the corrosion, that is the rusting of iron and the reaction of it. So let's see, what is corrosion? Corrosion slowly coats the surface of metallic objects with oxides or other salts of the metal. So when this metals comes in contact with the atmosphere, that is air and moisture, unwanted substances like oxides and other salts of the metal will be deposited on this metal, and what happens now, this metal won't be useful. It corrodes the metal. Okay. Now, rusting is an electrochemical phenomena. Okay. It is an electrochemical phenomena. That is why we are studying in electrochemistry chapter, right? Okay. So, rusting takes place in the presence of moisture. If the reaction has to take place, means it must be under the presence of moisture as well as air. Right. So, in corrosion, a metal is oxidized by the loss of electrons to oxygen and formation of oxides. So what happens? The metal gets oxidized, it releases electron, that means it loses the electron, which is accepted by the oxygen, and it forms oxides. Right. Now, corrosion of iron occurs in the presence of water and air. So, let's see the reaction. In anode, what happens? Fe, iron, it's getting oxidized to Fe2 plus, and it releases 4 electron. It loses 4 electron. So, in anode, oxidation takes place. Fe becomes Fe2 plus and releases 4 electron. Okay. Now, the electrons which is released at anode, now it is released in the anode, right? So, the electrons released in the anode spot move through the metal and go to another spot on the metal and reduce oxygen in the presence of H+. Now, these electrons move to the cathode spot and it is accepted by oxygen and it undergoes reduction. Okay. So, let's see, in the cathode, oxygen in the presence of H+ ions accepts this 4 electron and forms water. So, this is the reaction which is taking place in cathode. So, the electrons which is released here is accepted by the oxygen. So, let's see the net reaction then. Iron, Fe plus O2 plus 4H plus this 4 electron, and this 4 electrons get cancelled. Okay. So, Fe plus O2 plus 4H plus forms Fe2 plus and water. So, this is the overall reaction. Okay. So, as said, oxidation takes place in the anode, Fe forms Fe2 plus. Reduction takes place in the cathode, oxygen, it is reduced into water. So, this is the reaction which is happening. And finally, what is formed? Rust is formed. Okay. We are talking about rusting of iron. So, the formula for rust is Fe2O3 XH2O. Fe2O3 XH2 is the formula for rust, or it is rust. Okay. So, I hope the rusting of iron is also clear for you. Now, let's move on to the next topic, that is prevention of corrosion. So, how you can prevent the rusting of iron, tarnishing of silver and all of that. Let's see how we can prevent corrosion. So, by covering the surface of the metal by paint or any other chemicals. Okay. So, you have generally seen, to prevent the rusting of iron, the iron is coated with paint or any other chemicals. The next method is cover the surface by other metals like tin or zinc. Okay. So, covering or coating the metal with zinc. With zinc specifically, the process is called as galvanization. Galvanization. Okay. So, either you can paint the metal, another method is you can coat the metal with another metal like tin or zinc. So, if you are coating the metal with zinc, this process is called as galvanization, and they are inert or react to save the object. So, what happens here is, if I am coating iron with zinc, this process is called as galvanization. Now, what happens? The zinc will react with the atmosphere. Okay, it will react and sacrifice itself, and iron will not react. So, the iron will be protected. So, this is another way. Now, an electrochemical method is to provide a sacrificial electrode of another metal. So, what happens is, which corrodes itself but save the object. So, if you are using magnesium and zinc, they will react. They will sacrifice itself, those metals will sacrifice itself and will save the other metal that undergoes corrosion. So these are the few methods by which we can prevent corrosion. So I hope corrosion and the rusting of iron, the reaction and the ways in which we can prevent corrosion is also clear for you. So by this we come to an end to this chapter. So I hope the electrochemistry chapter is clear for you. So we'll meet in the next session with the next chapter. So that's all for today. Thank you.